Okay, I'm back, and so the first thing I want to point out to you is if you're one of my students, what does it say? You will not need to know these formulas for the exam, but I did want to kind of include some mathematics here and show you where these various numbers come from for the speed of different earthquake waves. So as you can see, I've got the speed of the shear wave or the S wave, the secondary wave, and then I've also got the speed of the primary wave or the pulse wave. And so you'll notice that the two formulas are kind of similar in that they both include the density of the rock. So density is the mass of the rock divided by the volume of the rock. And so that is going to be given by the letter rho, which is that thing that kind of looks like a P. Okay, but it's the Greek letter R. You also notice that both the S waves and the P waves depend on how rigid the rock is. So that's called the rigidity. And every rock is going to have a different constant that goes with it. Okay, then you'll notice that P waves also depend on another property of rocks, which is called the incompressibility. So these would be constants that you would look up. So let's say that you want to know how fast does a P wave travel through limestone. Well, you'd have to look up the density of limestone, the incompressibility of limestone, and the rigidity of limestone in a book somewhere. Plug it into that formula, and then you could calculate how fast would that P wave travel through limestone. Okay, so here is just some examples of the speed of certain waves. So like for dry sand, the speed of an S wave is between 0.1 and 0.5 kilometers per hour. Okay, now let's look at the P wave. Now, do you notice something about those numbers? So for the P wave for sand, it's 0.4 to 1.2 kilometers per hour. So how does that compare to the S waves? So do you notice that the P waves are faster, which means they're going to arrive first, which is why they're called the primary wave. And then the S waves are going to arrive second, so that's why they're the S waves. Okay, now let's look at limestone. So do you notice that all the numbers for limestone are greater than the numbers for dry sand? And that's because the more rigid the material is, the faster the wave can travel through it. So limestone is more rigid than dry sand. And now look at, for example, granite. Granite is even more rigid than what limestone is. So the point is that these earthquake waves are going to travel at different speeds through different kinds of substances. So that's all that I wanted you to get out of that. All right, let's take a break, and when we come back, we're going to talk about how do you measure an earthquake.